Pulmonary ventilation is based on Boyle's law, which states that as volume increases, the pressure of a gas decreases. One respiratory cycle is equal to one sequence of inspiration and expiration. Normal, quiet inspiration is considered the active phase of pulmonary ventilation because it results from muscle contraction. So as air enters through the trachea, the diaphragm contracts and descends inferiorly, so the height of the thoracic cavity increases, and the external intercostals lift the rib cage, so the diameter of the thorax also expands, and both of these actions help to increase thoracic volume by about 500 milliliters, and because the volume is increasing, the pressure decreases, and this decrease in pressure causes the air to enter the lungs. So the intrapulmonary pressure is less than the atmospheric pressure, and when these two pressures become equal, that's when inspiration ends.
Expiration is the act or process of releasing air from the lungs through the nose or mouth, also known as exhalation. There are two types of expiration. The first is quiet, a passive process that relies on lung elasticity rather than muscle contraction. Diaphragm and external intercostals are relaxed. Lungs and thoracic wall recoil. Both thoracic and intrapulmonary volumes decrease, which in return increases pressure. This pressure compresses the alveoli and increases pressure about 1 mmHg above atmospheric pressure. When intrapulmonary pressure is greater than atmospheric pressure, gas flows out of the lungs. The next form of expiration is forced expiration. Forced expiration is an active process produced by contracting abdominal wall muscles such as the obliques and transverse muscles. These contractions increase intra-abdominal pressure. This pushes organs superiorly against the diaphragm. Intercostal muscles also help depress the ribcage in order to decrease thoracic volume. An example of this muscle control would be how a vocalist has the ability to hold certain notes. Next would be non-respiratory air movements. Non-respiratory air movements occur when a person alters normal respiratory rhythm. Examples of this would include when a person coughs, sneezes, cries, laughs, hiccups, or yawns.
There are three physical factors that affect and influence pulmonary ventilation. These factors are airway resistance, alveolar surface tension, and lung compliance. The formula for the relationship between gas flow, pressure, and resistance is F equals delta P over R. Each breath allows approximately 500 milliliters of air into the lungs, and only 2 millimeters of pressure is needed. Surface tension is the tension produced at a liquid surface caused by the unequal attraction of gas molecules. The major component is water, which is a liquid film that coats the alveoli. Water has high surface tension and reduces alveoli to their smallest size. If film was purely made of water, each alveoli would collapse between each breath. The film that covers each alveoli contains surfactant, which is a detergent-like complex of liquids and proteins that reduces the amount of surface tension. More surfactant is released with deeper breaths to ensure that the alveoli do not collapse. Lung compliance, which is CT, is the measure of change in lung volume that occurs with a given change in transpulmonary pressure. The formula for this is CT equals delta VL over delta P pulmonary minus P intrapulmonary. A healthy pair of lungs has high compliance due to the lung extensibility and low alveolar surface tension.